Welcome to this skill builder on the chi-square test. In this session we'll be covering what a chi-square test is and when we can use one. The chi-square test is a type of non-parametric test that's used to measure the association between two categorical variables. We use it when we have observed frequencies or counts of a categorical variable, for example the number of males versus females or number of healthy versus sick individuals. There are two main types of chi-square test that we'll cover. One is the chi-square goodness of fit test, which is used to compare the observed frequencies in a data sample with frequencies that are based on some kind of prior expectation, which could either be empirical or theoretical. The other is the chi-square test of independence, which assesses whether observed frequencies are dependent on certain conditions. A chi-square goodness of fit test uses a frequency table to display the number of occurrences in each level of a single categorical variable. In this example, we want to investigate how many times different species of birds visit a feeder in a 24-hour period. Bird species is the single categorical variable, and there are different types of species that come under this category. We're testing our observed frequencies against a prior expectation which is based on the average number of different species that have visited this bird feeder over the last 5 years. Our null hypothesis is that our observed proportions of different bird species will be the same as the 5-year average. Our experimental or alternative hypothesis is that the species will visit the feeder in different proportions from the 5-year average. The chi-square test of independence uses a contingency table to display the distribution of two or more categorical variables. In this example, we want to find out whether there are different proportions of left-handed people depending on nationality. In other words, we're testing whether handedness is contingent on nationality. So in this contingency table, we have right and left-handed Americans and Canadians with the number of observations for each combination. We can use this test to find out whether our observed frequencies are significantly different from the frequencies we'd expect if handedness were unrelated to nationality. Our null hypothesis is that the proportion of people who are left-handed is the same for Americans and Canadians. Our experimental or alternative hypothesis would be that the proportion of people who are left-handed differs between nationalities. Both the chi-square goodness of fit test and the test of independence use the same formula to calculate the chi-square statistic. We don't always need to learn this formula off by heart, as we usually have software to do this for us, but this formula is fairly straightforward to understand, so it can help you to get to grips with how the chi-square test works. We calculate the chi-square statistic by taking the observed frequency minus the expected frequency and squaring it. This is then divided by the expected frequency. The larger the difference between the observations and expectations, so O minus E in the equation, the bigger the chi-square statistic will be. When determining the statistical significance of the chi-square test, the p-value indicates the probability of observing the obtained chi-square statistic, or a more extreme value, under the assumption that the null hypothesis is true. Typically, if p is less than 0.05, you may conclude that there is a significant association between variables, accepting the experimental hypothesis and rejecting the null hypothesis. For guidance on the broader range of stats tests, please go to the Skills for Academic Success website at kent.ac.uk/SAS, where you can view more of our numeracy and statistics videos. You can also book a one-to-one appointment with one of the SAS team.